Well, hi there. This is Dr. Dell, and this is the final interlude that we've come to in the Teaching Math book. And of course, I'm Craig Hain, known as Dr. Dell to my students, and you can learn a lot more about all of this at triadmathinc.com. And what I want to talk to you about today is more about the complex numbers. We discuss and teach the complex numbers in Tier 4 of our 10-tier system. That is in Tier 4, as I've told you before, we go through George Simmons' book for the second time, making sure we cover all of the proofs, some of which were a little too deep, we felt, for Tier 3. And this, of course, is the marvelous book that is for pre-calculus math. But we think that in pre-calculus math, or I guess I should say I think in pre-calculus math, that you should cover complex numbers because the complex number system is extremely important in all types of subjects in engineering and science and modern math. In fact, it's just a critical thing, and indeed, you need it really very early on. You can't even solve a lot of quadratic equations without the complex number system, as you very well know. And that's true. So if you can't even solve quadratic equations without them, then you know you need them pretty bad. And that's just the beginning. Now, the complex numbers are kind of difficult to understand if they're not taught properly, and unfortunately, in my experience, has been they haven't been taught properly very often. And so we teach them in what we think is the proper way. Students seem to understand them very easily when they're presented this way. And one of the questions that I would ask somebody to determine whether I think they understand complex numbers in an appropriate way is, what is I raised to the I power, where I, of course, is the square root of minus 1. Now, that certainly is not something you're going to find on this calculator that we use in the foundation course. You could find it if you go to more powerful tools, obviously. But the question is, how could you figure that out? If you go to Wolfram Alpha, for example, it'll just tell you the answer. The answer turns out to be a real number. It's 0.2079. Who would guess that I raised to the I power would then be a real number, 0.2079? And how in heaven's name did they come up with that? Well, the key to understanding that is this most important equation that you have to explain, of course, in detail to students, which is that e to the I theta, and that theta shouldn't be an exponent, just e to the I times theta equals cosine theta plus I sine theta. And what that amounts to is, and I'm going to give you just a little quick discussion of it. You take the unit circle in the complex plane, and that means that every complex number on this circle has length 1, and this is the real number 1, and this is the real number I. This is the imaginary axis. And if you take any complex number on that circle, and if this is the angle theta, then this will be cosine of theta plus I sine of theta. Now that's something that you learn just in very early basic complex numbers. Then what you learn and what you need to teach people is that this number here can reasonably be defined to be e to the I theta, and so you can treat this as a definition, but of course, like any definition, you have to motivate it. And if you are a teacher or a person that understands complex numbers, you know this formula and you know where it comes from. Basically, you are using the real Maclaurin expansion of e to the x and cosine of x and sine of x, and plugging in I theta and showing in a formal way that these then are equal if in fact it's meaningful for complex numbers, and indeed it is, and ultimately you're defining e to the z, where z is any complex number. Okay, now if you didn't know this and understand it, you probably didn't follow what I just said, and that's okay, but just take this then as a definition for now. And then you know the rules of exponents. If you take e to the I theta and you raise it to some power, I'll say n, for example, then this is e to the I times n theta. And of course, from that comes the famous formula that the cosine of n theta plus I sine of n theta um, is equal to sine of theta. I'm sorry, cosine of theta plus I sine of theta raised to the n power, the famous Euler formula. And one of these equations is what Richard Feynman, the great physicist, thought was the most beautiful equation in math. I forget which one it was now, but this is a very, very profound equation that relates real functions to complex functions through their infinite series power expansion and so on. And that's what we explain in our treatment of it. Now, having said that, then this would be e to the I theta. And so what would this point be? Well, what's the angle here? Well, the angle here is pi over 2. So I is equal to e to the I times pi over 2. Okay, so that is another way of expressing I. Now we use the rule of x, the law of exponents, and we take this I raised to the I power is e to the I times pi over 2, all raised to the I power. And that becomes the same then as e, because this comes inside as I squared pi over 2. And of course, as you know, e to the I squared is minus 1, so this is e to the minus pi over 2. And that's the answer then. And then at this point in time, now that you're back down to a real number, you can take, with this calculator, you can take pi, divide by 2 equals, make it negative, and then you enter that into the e to the x thing, and there's 0.2079 if I restrict that to 4 decimal places, and that is, of course, then the answer for that. Now, I went over this fast, and if you do not understand complex numbers, if, for example, you are a student or you're a homeschool teacher reading this book and you don't know this probably was just all Greek to you, and you say, oh my God, I have no idea what he's talking about. This is terribly confusing. Indeed, it wasn't intended to teach you this from first principles. It takes us probably, I don't know the exact count now, but probably 10 lessons to get you up to this point in our treatment of complex numbers. You certainly don't get there right away, but you can get there fairly quickly. In fact, when you finish the complex number treatment in the 4th tier of our training, you will understand complex numbers in a very, very profound way and in an appropriate way, so you'll be prepared then to use them when you go on into more advanced math where you have to have them. You don't get too much further in math before you really have to have complex numbers to solve a lot of problems. And in fact, in the teaching math book, I actually gave you a list of topics where they're critically important that came out of Wikipedia, just so that you can see I'm not making this up myself. And they're just used in all sorts of things. In fact, I consider the fact that we are not teaching complex numbers properly to our high school students today a really gaping hole in our math curriculum. Now, as you know, I believe that we're doing a lot of other things wrong or less than optimal in our math curriculum today, and that's what this book, Teaching Math, is all about. If you are indeed interested in teaching math at the high school level, either in a classroom environment, which of course is very challenging, I acknowledge, or if you're going to teach someone one-on-one, such as a homeschool teacher, or maybe you're a parent and you have a student who's struggling with math and you would like to help them, then you need to use some of the more automated tools. And of course, if you go to triadmathinc.com, I talk about that a lot, and what I recommend to you is the foundation course to start with. Now, we don't get into this complex numbers in the foundation course. This is to provide the foundation to build on. Then once the student is through this course, then you can go into the upper tiers, tier 3 and then tier 4. You won't get to this until tier 4. So I was a little bit trepidatious about presenting this in at this point in time because I don't know who my readers are. I don't know what your background is, but it gives you an idea then of the kind of things that you should be understanding if you're going to be a really effective high school teacher and going to go beyond the most basic things. So, this is Dr. Dell. I hope that you find mathematics as fulfilling and valuable in your life as I have. It's an extremely important subject, especially in this modern economy that we're in with all the modern technology. And of course, that's what I talk about in the Teaching Math book, as you know. You're reading it presumably. So I wish you the best in your future endeavors. And if you do decide to take some of our training, then I will see you on some of those training videos. So, this is Dr. Dell. I wish you having a very wonderful, successful life. Bye-bye.